All right, guys, we're going to be doing day 10 today. And so we're on day 10 warm-up of unit 5, and it says for n and p greater than 0. And so there must be a reason why they're telling us p is greater than 0. Maybe it ends up on the bottom of a fraction or underneath a radical. And so you don't have to do anything with that. They're just telling you that in order for the problem to be valid. And they want to know, is that expression, and that's quite the expression, pretty ugly, okay? Is that equivalent to this? So basically, guys, we're going to have to see if we can get what we have on the left equal to what they have on the right. However, they're asking, is it equivalent? So it might not end up being equivalent. So we'll have to see if it does end up being equal or not, and then we can answer the question. All right, so what I see first here is I see parentheses with a little 8 exponent up here. And so I know that we have to raise not only the p squared to it, we also have to raise the n to the 1/2 to it. So I'm going to go ahead and write it like this. I'm going to have p squared raised to the 8th, and then I'm going to also have n to the 1/2 raised to the 8th. Okay, and I'm going to figure out what this is first, and then I'll worry about the radical that comes next. Remember, guys, that when you have an exponent raised to an exponent, you multiply them. And so this is going to end up with p to the 16th. 2 times 8 is 16. Okay, remember to multiply them. Same thing, guys, with the 1/2 power and the 8th power. We're going to multiply those as well. And 1/2 times 8 is going to give us n to the 4th. Okay, so that's not that terrible. I'm going to go ahead and put this in parentheses, and now I'm going to go ahead and take a look at what I have here. Remember, guys, that a square root, there's a 2 in the crack. And so if I want to turn this back into not being a radical, I would have p to the 5th, n to the 4th. It's all underneath the radical, and so I'm going to make sure that it's grouped in parentheses, and it's going to be raised to the 1/2 power. Okay, so I just rewrote our radical into a fractional exponent. And that kind of turns into what we had going on over here. So we're going to have p to the 5th. That's going to be raised to the 1/2 power. And we're also going to have n to the 4th raised to the 1/2 power. Okay, and so when I go ahead and multiply my exponents again, 5 times 1/2 is 2.5, which is a fraction of 5/2. And then n raised to the 4th times 1/2, that's going to be 4/2, which is the same thing as 2. So n to the 2nd. Okay. So basically, again, guys, because that 2 is in the crack and they're both underneath there, you're basically putting that 2 on the bottom of the 5 and on the bottom of the 4. All right. It's just that 4/2 reduces to just a 2. All right. So now that I have them, I am ready to go ahead and see what I end up with. But p to the 16th times p to the 5/2, because your operation is multiplication in between here, guys, you're going to take those exponents and you're going to add them. And so when we take 16 and we add 5/2 to it, all right, we end up with, is that 18.5? Okay, so we end up with p raised to the 18.5. Or you can math bracket and have your decimal go to a fraction. And then we're going to do the same thing, guys, with n to the 4th and times n to the 2nd. We're going to add those exponents, and we're going to end up with n to the 6th. All right, so taking a look, guys, at what they gave us up here and asking us if it's equivalent to it or not. We do have p to the 18th, but we have p to the 18.5. Okay, so remember, guys, that we also have this p down here, and we know that there's a 2 in the crack and a 1 on the p, guys. And so if I rewrite this as p to the 18th, n to the 6th, and then I rewrite that radical as p to the 1/2, right there, guys, p to the 18th and p to the 1/2, if you add their exponents, you get p to the 18.5 and n to the 6th. And you guys can see that that is actually what we have also. And so we're going to go ahead and say, is this expression equivalent? And we're going to say yes. Okay, so there's our answer. And it says to justify your answer, and we have justification. Justification just means that you have to have your math being shown. And so right here, guys, we can see that they're equal, and we can also see how we made them equal with all the work above it. And so this is done. Okay. All right, so I will see you guys on day 10 notes.